Hello and welcome to the third lecture in the R tutorial series for Professor Kozak's class. Today we're going to be talking about conditionals and loops. So before we get into conditional statements, we need to talk about another data type that was not covered in the last lecture, but it's very simple. And this is Boolean data, or Booleans. So the Booleans are used to compare between other variables. So for example, actually, let's say we wanted to set, we set R to be a random number. Our norm function does, where 0, standard deviation of 1. So a standard normal random variable. And let's say we wanted to check if x is greater than 0, which it should be half of the time, approximately. So what we could do for that is we could use this comparison operator, and there are 5 comparison operators that we're going to go over, this one being greater than. So this will check whether or not x is greater than 0, and it'll return true or false. True if it is true, and false if it's false. The 5 comparison operators we're going to show you today, and there are more, but these are the important ones for now, are greater than or equal to, which is just the greater than symbol, and equals, less than or equal to, and exactly equal to. Note that the exactly equal to is done using double equals, and so it's very common to, when you're trying to do a comparison to find if x is equal to 0, a common error is to only put a single equal sign. And that'll assign the x to be 0 rather than check whether or not x is 0. So it's important to have that second equals. So okay, so now that we've gone over what conditional statement or what comparison operators are, let's go ahead and use them with our first conditional statement. So the first thing we're going to want to do is let's see if we can. We're going to want to check. Let's check and see if x is greater than 0. So first of all, find our norm function. But then let me show you what I'm doing here. So this is an if. This is the first conditional statement, an if statement. And what this will do is you're going to just put if, and then in parentheses you're going to put the conditional you want to evaluate. So for example, here we're evaluating if x is greater than 0. And then what's going to happen is if this evaluates to true inside of these parentheses, then the code put in between these curly braces that follow the if statement will be executed. So for example, if x is greater than 0, we could print greater than 0. Okay, so let's run this code. Let's leave this line, but notice that it did not print x is greater than 0 because, as you can see here, x is negative 0.81805. Let's run it again. And now we did get an x that is greater than 0. And you can see that it printed out x is greater than 0. So, okay. And you could put any arbitrary code in here. You could say, if x is greater than 0, set x equal to 100. And, negative 0.68, so it's not gonna, but it was some value greater than 0, so now it got set to negative 100. So any code you want to put, you can put inside here. You could put even additional if statements if you want to, but that gets a little bit more complex, and that's kind of beyond the scope of this class. Okay, so now that we've shown how to do conditional execution of code, so that's what this is conditionally executing code depending on whether or not x is greater than or equal to 0, or greater than 0. We could get into the next conditional statement, which is the else statement. So this is pretty simple. The else statement is just going to get evaluated whenever if the conditional in the parentheses after an if statement is false. So every time, if x is not greater than 0, then we could check to see, then the else statement would happen. So for example, we might say And let's source this. And so you see for negative, like that. This could also be accomplished. Note that this could also be accomplished by saying if x less than or equal to 0, by doing another if statement. That this would accomplish the exact same thing. But it's in general, it's much nicer and much cleaner to just use an else statement than to try to create the negative of it, of the original conditional, because you can make mistakes with that and it takes longer to type, and it's just generally better practice to use an else statement for that kind of when you're just trying to get the negation. So, okay, now let's get into the third type of conditional statement, an else if statement, which is basically just a combination of the two previous conditionals. An else if statement would say, would only execute if the if statements before, all if or else if statements before it had evaluated to false, and the conditional inside of the parentheses here also evaluates to false. So for example, I might say else if x equals 0. And then else and so this would only be executed if, actually, we'll just for the sake of just for the sake of these, or for the sake of being able to show the code, let's say if x is less than 0, we'll execute this, else x is 0. And so if we execute this a bunch of times, we'll see that this is going to go ahead and, depending on the value of x, you're going to print out you're going to print out some statement or run some code. And if, for example, we set x is assigned to 0, the else statement. And let me, so okay, so that is the conditional statements. There's one last thing I need to teach you about Boolean variables before we can move on, and that is the negation operator. So, so let's say we want to do, x less than 0. But what if we wanted to negate that? As in, you want to get if x is not greater than 0. Sorry. All that you need to do for that is just put this exclamation mark before the operation, and that'll negate it. So that'll turn all falses to trues and all trues to false. And that could be something that you can use for for evaluating different kinds of Booleans and stuff like that. It's just a little quick trick. So it's the equivalent of doing an else statement. Doing this would be the equivalent of an else statement. Because it's evaluating the exact same Boolean. Okay. Cool. So that's all with conditionals. Let's talk about. Oh, wait. One last thing that we need to talk about with this before we can do anything else. The order of operations in terms of if statements. So let's say we want to do a complicated if statement. X is equal to 0. Let's say we wanted to do y is there's going to be a random variable with y is a random variable with limit of 10 and the standard deviation of 1. So let's say x is greater than 0. What if we want to do a conditional that was if x is greater than 0 and y is, and y is greater than 0? Well, what we can do is we can do this we can use this and operator, which essentially says both things need to be true for this to return true. Or if any of them are false, then it'll return false. So, example, y greater than 0. Let's execute this code for a second. Okay, and this worked because both of them are greater than 0. But this time it didn't work because one of them evaluated false, And let's say we were to set this to 10, this to, and this to negative 10. Note that this also won't work because even though x is 10, y is now negative. So both of them need to evaluate the value of true. And another operator like this is the OR operator, which is just an straight up and down line, which will say essentially, which just means that one of the two needs to be true for this to work. So for example, if both are true, and if both are true, it'll still work. But if one is true, it'll still work. And if the other is true, it'll still work. But if both are false, then it will not work. So that is, the majority, that is conditional statements. Now let's move on to loops. Let's start with the problem action. So let's say that I give you that x is from 1 to 200. So it's every variable. So this is going to just go ahead and make x an array that is every number from 1 to 200. But let's say I want to find the number of values and the number of different numbers in the range from 1 to 200 that are divisible by 5, that are evenly divisible with no remainder. So how would we do this? Well, one way to do it would be to brute force it, to essentially go through and say, okay, 5 is divisible by 5, 10 is divisible by 5, 15 is divisible by 5, 20 is divisible by 5, and brute force and figure it out like that. An alternative might be, if you're really good with patterns, you might notice that 5 and 10 are both divisible by 5. So out of every 10, and every number that's a multiple of 10 or 5, or sorry, every number, for every 10 numbers in the sequence, 2 of them will be divisible by 5. So there'll be 5, 10, 15, 20, 25, 30, etc., etc. So you might be able to say, okay, so every 10 numbers is 2 5s, and there are 20 sets of 10 inside of 200, so therefore there should be 40 numbers divisible by 5. That would be a fair way to do this. But let's see if we can get the program to do this for us without having to do any math ourselves. How we might do this is we could say, we can use what's called a for loop. And the format for this is going for parentheses, and then what you're going to put is a variable you're going to use as your iterator, which is I in this case, and then in, and then the variable what you're trying to iterate over. So in this case, X could be a numeric array or any type of array. And then what will happen is I will take on every possible value of X. So let's take an example. I'm going to go ahead and lower this down to 20. And let's print off. Let's just run some arbitrary code. Okay. So and let's go back to, let's debug this. Let's put a debug bit right there. So when I source this code, what you're going to see is that X is 1 to 20. And on the first iteration through, so what's going to happen, by the way, is each iteration through, I is going to take out one of the values in X from the first value to the very last at the end. And by putting a debug bit here, what I'm doing is I'm stopping the code on this print statement each time through the loop. So right now we're stopped, and I is 1 in this case. But if we hit continue, which will continue to run the debugging session until it hits the next debug stop point, which is the next time through the loop it'll stop. We now see I is 2, 3, 4, 5, 6, 7, etc. Okay. So now you can see what a for loop does. It just, and if we were to say X is then do this. So now it's going from 1 to 20, but iterating to 2. We would see that X is 1, 3, 5, 7, 9, and you see that these are the elements of X that I is taking them on at each time through the loop. Okay, so now that we've seen that, let's look at let's go back to the problem we had at hand, which is going from 1 to 200, finding all numbers, or finding the number of numbers that are divisible by 5 from 1 to 200. Well, what we're going to do real quick just to set this up, we're going to say if 5 count to the variable equal to 0, that's going to be the count of the number of times that we've found a variable that's divisible that's evenly divisible by 5. Now what we're going to do is we're going to go, okay, so we're looping through all of the possible values of x, which is from 1 to 200. Let's see if each individual value of I is divisible by 5. And so a really slick way to do this is to say if I divided by 5 is equal to round I divided by 5. So let's look at what that does for a second. Let's say I is 9. Let's look at what this statement does. This is going to, I can tell you right now, what this is going to do is this is going to tell you whether or not I is evenly divisible by 5. Let's see why. So in this case, it's not because I is 9. So let's look at what I divided by 5 is. 1.8. And then let's look at what this round function does. So round, say for, round is going to take round is essentially going to chop off all decimal places when you use it. So for example, or not chop off all decimal places, it's going to round up or down, depending on the numbers is greater than 0.5 in the decimal place, or if it's less than or equal to 0.5 in the decimal place. For example, 4.5 is going to go round down to 4, but 4.6 will round up to 5. And so all this really is doing is this is chopping off all that we really care about is that it's chopping off the decimal place in this number. So, but what's important here is that if we go I divided by 5, if we go rounding I divided by 5, the only time this will be the same as I divided by 5 is when there is no decimal portion to I divided by 5 in the first place. So in that case, this if statement here says basically, which is essentially saying, is I divisible by 5? Okay, so now that we've got a conditional to check that, all we need to do is do this div5 count, and I'm going to do another slick trick here, which is assigning a variable equal to itself plus 1. And this is called iterating a variable. It's pretty common practice in a lot of programming languages, but essentially what it's doing is you can assign a variable equal to itself, and all it'll do is this variable is equal to its previous value plus 1. So for example, if this were 1, if this, if the first loop through this is 0, then if this gets evaluated, this would become 1, and 2 and 3 and 4 and 5, and just keep iterating up. And starting out at 9, it would go to 10, 11, 12, 13, 14. So, okay. I'm going to put a breakpoint on this if statement. Now remember that the breakpoint is before the code gets executed. So let's see how this code works now that we've sort of gotten into this. So what we're going to see here is that the first time through I is 1, our diff count is 0. So that's as expected, and we expect, and remember that this is before the if statement gets executed. So we're seeing the, so even when this value is set to 5, even when, I is divisible by 5, this diff count isn't going to be jumped immediately. It's after we finish up this loop, after each loop, that's going to be added, or it's going to be increased because we haven't quite gotten to this code yet, and we haven't really gotten inside of it yet. So, okay. So we don't expect diff count to jump until I is equal to 6. Remember that. Because we are looking at it before the code is actually executed. Okay, so at 5, it's still 0. And at 6, it goes to 1. And at 11, it goes to 2. And I think you can see what it's going to do from here. Okay. So now let's see what this code gives us for a final solution. So I'm just going to source it, see what diff count is. Again, it's 40, exactly what we'd expect. Okay, so this is the basics of for loops. And what's really important for for loops here is that for loops are best used when you know the number of iterations you're going to be going through. For example, in this case, we know that we're going to be doing 200 iterations because we know where we're going. We know how many numbers we're going to. But let's say you don't know how many iterations you're going to be going through. Let's say I ask you, find me the first 27 numbers that are divisible by 7 from 1, starting from 1. And I mean, you could theoretically do a for loop through 1 to 1,000 and find all those numbers. But if I were to say, to the find me the first 1,000 prime numbers, you wouldn't. I mean, maybe you could figure out what the largest of the prime numbers is of the first 1,000, but you wouldn't. You wouldn't be expected to know that off the top of your head. So I'm going to teach you a tool for that a loop you can use when you don't know the number of iterations going to be good. So first of all, for anything else, let's go ahead and set, we're looking for 7 div count, or div 7 count is going to be 0. We're going to set a variable that's going to be basically holding that count for how many numbers we found. And let's say set array, an empty array for right now, that's going to hold all these numbers that are divisible by 7. So we're going to show you how to concatenate to that in a little bit, but for right now it's just going to stay empty. So what we want to do is we need one more thing. We're going to set I is assigned equal to 0. We're going to start out at 0 because I'm going to show you that you're going to have to iterate it inside of this loop because it's a little different. So what we're going to use is what's called a while loop, which is very similar to a for loop in that it uses in syntax in that, well, it's similar, but here's the difference. The while loop works where instead of going through all the different values of, where I was going through all the different values of X, what a while loop would do is it'll continue executing the code below it until, as long as the statement inside of the parentheses is evaluates to true. When it evaluates to false, it will jump beyond the loop and execute and won't execute the code anymore. So for example, to solve this problem, we're going to essentially say div 7 count, while div 7 count is less than 27. So we'll start with 2 for right now. While div 7 count is less than 2, we're going to want this to keep going. So this is essentially saying as long as that number is less than 2, we're going to keep iterating through and through. So what we want to check here is we're going to go I equals I plus 1. So we start out at, so that way on the first iteration through I becomes 1, then 2, and then 3, and then 4, all the way out to infinity until this while loop stops executing. It's important for while loops, by the way, that you do have an exit condition, a feasible exit condition. Otherwise, you'll get what's called a runtime error, where your computer will keep going to infinity. Because you can say, if I didn't put div count was set to never change throughout any of this, then I would just keep going, and it would just keep going and going and going and going and never stop. So you want to always have solvable exit conditions, but that's more of an implementation detail than anything. So let's go ahead and use an if statement here to say if I is, and you're going to use the same stuff that we did before, if I divided by 7 is the same as a rounded version of I divided by 7, then we're going to go ahead and execute and say div count is div count, or sorry, div 7 count is what we're looking for. Div 7 count is equal to div 7 count plus 1. And let's go ahead and concatenate let's go ahead and concatenate the value that we just found to the div 7 array. So that's going to be, the way you can concatenate an array is you essentially go C, and then you put the array as it is right now, and then whatever you want to concatenate to the end of it. And that will allow you to add values into it. So now we're going to add I into this. And this concatenates to the back of the list of the array by putting it this way. Or if I want to do it at the front of the array, I could do I concatenate I div 7 array. We want it at the back because it's going to look a little nicer. So, okay. So what this code is doing, all that this code is doing is it's doing, while this div count is less than 2, we're going to keep executing all the code below. And what the code below does is it goes, iterates on I, makes it larger, enumerates I, And then we're going to go ahead and check this if statement. If I is divisible by 7, then we're going to increase the div count by 1, and we're going to concatenate this new number to the end of this div 7 array. So okay, let's see how this code works. Let's not do a second breakpoint, actually. This is one of the problems, is having 2 breakpoints in the code. Don't worry about why, it's just a function of the, it's just a problem of, well, it's an issue with R, but it's not that important for now. So, okay, so we're gonna go through 1, 2, 3, 4, 5, 6, 7, and now the next iteration through div count increases, and our div 7 array is now just 7. So if we keep going through, at 14, after 14, our div 7 array became 2, and our div count became 2, and so this thing stopped executing. Okay, so now let's go back to the original task I assigned you, which is finding the first 27 numbers that are divisible by 7. So let's go ahead and take out the breakpoint. Let's see what this finds for me. Okay, go ahead and look here at what div 7 array is. It's now going to be the first 27 numbers that are divisible by 7. Okay, so that is, and remember that while loops are best used when you don't know the number of iterations like we did here, whereas for loops are preferred when you do know the number of iterations you want to go through. So that has been conditionals and loops. Next lecture, we're going to talk about functions. Thank you very much for your time, and have a nice day.